Homework help. You get homework help. Let's start. Alright, here we go. It's homework time. You're here. I'm here. We're doing homework. Let's get down to it. You should be on page 126. And last week we learned about equivalent fractions. Now it's all about comparing fractions. And you'll need some of that equivalent fraction knowledge to help you. Not right away, but trust me, you'll see what I mean soon enough. First, just look at this picture. Adriana ate 2/4 of a granola bar. Right here, you can tell that's definitely what Adriana did because there's 1, 2, 3, 4 pieces, just like the numerator says, and 2 of them are shaded in, just like, wait, that's denominator, sorry. Just like the numerator says. Numerator, denominator. I don't know if I said that right the first time. Blech. And now here we go. We have June, someone named June, who ate 2/5 of a same size granola bar. So 1, 2, 3, 4, 5. Yes, that's the denominator. And then 1, 2 shaded in. That's the numerator. Cool. Which girl ate more granola bar? And since they're the same size, it's pretty easy to look at the two and go, ah, this one looks like more is shaded. So 2/4 is in fact bigger. That's my bigger than sign. 2/4 is bigger than 2/5. And we get to move on. Use the math you already know to solve the problem. How many equal pieces of granola bar did Adriana eat? Well, her fraction was 2/4. And how many did she eat? Well, she ate 2 of the pieces, so 2. How many equal pieces of granola bar did June eat? Well, she ate 2/5, right? And how many pieces was that? Out of 5, that was 2. So if you look at that, you might go, whoa, whoa, whoa. Since both girls ate the same number of pieces, what can you look at to find out who ate more? Well, remember, we already discussed that 2/4, Adriana, 2/4 was greater than 2/5. You can see that right there. A little more is shaded than over there. So if 2/4 is bigger than 2/5, the top numbers are the same. What can you look at to decide which one's bigger? You look at the denominator. You look at the bottom number. And if the top number is the same, then whichever bottom number is smaller has the largest fraction. And that's because less pieces, like imagine that the bottom number is how much you have to split it up into. And when that bottom number is smaller, that means you're splitting it up less. That means the pieces are actually bigger. So I know it's hard to think that way. It's kind of counterintuitive, but think about 1.5 and think about 1/10. Which one's bigger? Well, you might go, oh, there's a 10 over there. That was... No. 1/2 is bigger. What? I don't get it, mister. Well, check it out. Make a circle for 1.5. Make a circle for 1/10. With 1/2, this is how big the pieces are. Because look, there's 2 pieces. 2 pieces, 1 and 2. And one of them gets shaded in. Look how much gets shaded in when there's only 2 pieces. But with 1/10, you got to go, okay, there's 2 pieces, 4 pieces, 8 pieces. Oh my goodness, so many pieces, 9 pieces, 10. There's so many pieces, and when you shade them in, that's how much gets shaded in. Which one had more shaded in? 1/2 or 1/10? It's totally 1/2. Yeah. So what can you look at? Since both girls ate the same number of pieces, what can you look at to find who ate more? The smaller denominator ate more. There you go. Simple as that. The smaller denominator ate more. What does the size of the denominator tell you about the size of the pieces of the granola bar? So we just talked about that. So the smaller the denominator, the bigger the pieces. So when we're talking about size, smaller denominators, smaller bottom numbers mean bigger pieces. Remember that. That's super important. Smaller denominator, bigger pieces. Smaller denominator, bigger pieces. Who ate more? Adriana ate more. Adriana ate more because her fraction had the smaller denominator. Not numerator, denominator. Numerator works differently. One more second. I know you guys probably write slower than me, so dip 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 dip. Write that. Okay. So here's one more comparison of the fractions we were dealing with already. 2/4 is greater than 2/5, or you could say 2/5 is less than 2/4. As long as you see that 2/4 is the big one, and 2/5 is the little one. And it might be hard to see that in numbers if you don't remember that smaller denominator means bigger pieces. But you can certainly see it in picture form, can't you? How this one's shaded a little bit higher than that one. See, 2/4 bigger than 2/5. Okay, moving on. Last thing, here's a whole bunch of nonsense. We'll look at that in a second. Explain how you can tell which fraction is greater, 2/5 or 3/10. This right here, my friends, is where common denominators are so important. You have 2/5. And you also have 3/10. Okay? And you want to say, hey, which one's bigger? Which one's bigger? But it's so hard to figure out. Like before, you have to draw a perfect rectangle and shade it in just right, and maybe you don't, oh my god. How can we figure it out and be absolutely certain which one's bigger? Well, the best way to do that is to make the bottom numbers the same thing. Make the bottom numbers the same thing. And right away, think to yourself, I've got a 10 and I've got a 5. Can a 5 become a 10 through multiplication? Think about that one more time. Can a 5 become a 10 through multiplication? It sure can. Think about your times tables. 5 times blank does equal 10. 5 times 2 equals 10. And remember, with fractions, whatever you do on the bottom, you must also do on the top. You have to. It's just a rule. Do it on the bottom, do it on the top. Do it on the bottom, do it on the top. So 2 times 2 equals 4. So we've taken our 2/5 and we've transformed it into 4/10. We did an equivalent fraction. We've kind of already learned that. And you might say, but Mr. Graham, it doesn't say to make an equivalent fraction. It says, can you tell which one is greater, 2/5 or 3/10? Well, since we turned 2/5 into 4/10, we can see which one is greater. Because look, the bottoms now, the denominators are now the same. We like that. That makes it simple. That makes it very, very simple. That's what we always want. We always want the denominators to be the same, pretty please, with sugar on top. What we don't mind is if the tops are different. The tops can be different. In fact, we like that the numerators, the tops are different, because they want us to know which one's greater. And if you look at them, a 4, a 3, well, that takes 1 second to figure out which one's greater. What's greater, 4 or 3? What's bigger, 4 or 3? A 4 is bigger. So 4/10 is greater than 3/10. And where did our 4/10 come from again? We just found an equivalent fraction for 2/5, right? So it's important that you understand this. Check it out. 2/5 and 4/10 are equivalent fractions. they are the same. And 4/10 is greater than 3/10. So that means that 2/5 is also greater than 3/10. So how can you tell which fraction is greater? First, turn 2/5 into an equivalent fraction of 4/10. Then compare 4/10 to 3/10, and you will see that 4/10 is bigger. So 2/5 is the greater fraction. Now this is the first night, and they're asking you to understand a lot right away. Don't be scared if it's hard at first. Just stay with me and we'll keep practicing, okay? We'll go over it in class. Every practice day, we'll go over it in class, okay? You'll get better and better. So thanks for joining me, guys. That's all we have for tonight, and I'll see you next time. Bye.